The problem with this demonstration, by the way, and the literature will tell you not to do it with a plastic bottle, is because the ethyl alcohol leaches the plasticizer from the bottle, and so they crack after a while. But I've been using this bottle for over 10 years, and the reason for it is you see what I'm doing. Immediately after use, I reverse it and allow all the alcohol, residual alcohol to vaporize, so it doesn't leach out, or it hasn't yet leached out any of the materials. Now, I don't have to worry about that with this one. This is
On the table.
on the table, thank you. This is a different alcohol. This is rubbing alcohol. It's only 70%. So I have a glass bottle here to use that in. But I'll do the same type of thing. I'll put it in about an ounce or so. And we'll roll this around to see if we can generate some vapor. And we can do a direct comparison to see if ethyl alcohol burns as effectively as does ethyl alcohol. And this time, I'll brave the reaction. And I'm just going to drop this in and see what happens. Very much weaker interaction, right? But I'm handling it a little bit different. And of course I use this flask now because it's glass. And how am I handling it different? I put my hand over it. Why did I put my hand over it? When something burns, what happens? It what?
Consumes oxygen.
It consumes oxygen. Excellent. So what about the pressure in this bottle? Should the pressure in this bottle be greater, the same, or less than atmospheric pressure?
Less.
Adam, he's our pressure expert. Should it be less?
I'm guessing
Same?
less.
You're guessing. How can we test it?
More fire?
No? No? Just by lifting my hand. Well, what that does is it distributes the vapors in the container in such a way that you get an extraordinarily interesting reaction. This one is, I should actually turn. Watch what happens now. Watch very carefully. You see the ring of fire? I must be vegetable. I'm making oxygen.
One of those trick
Yeah. So that's called the ring of fire demonstration, and it requires only special liquids with special types of vapor pressure to give rise to it. But it's a really fascinating experiment. Now, if I went up, I should also be able to go down. In other words, here's another container and another alcohol. This is an alcohol that many of us, that we used in the lab last week. Therefore, this is, what alcohol did we use in the lab last week?
Scotch.
Methanol. Methyl alcohol, the small guy. So I'm going to take a squoosh of methyl alcohol and dump it in here. And I'll rub it to make it happy. And I'll see what I can do. Now, what's going to happen here? What do you expect to happen? What's different about this experiment?
On the outside? Sealed container.
Sealed container, right. So what happens now when I put a match next to a sealed container?
I'm more afraid of Marina's reaction.
I don't think I ever have to worry about having Marina in one of my courses, do I? Okay, what was the difference there? There, the difference was we were saying the same type of reaction, except it was in a closed container. So one had to release the pressure that was generated, which we gave this nice little pump. So I would say that all those were, filled the mandate of being visible in large scale. Yeah, VacMan. Have you ever heard of VacMan? It's about a 20-year-old toy. And it came, there is VacMan. Now what I want you to do, so here you can do it. Stretch VacMan, or put him in a crazy shape. Just kind of stretch his arm. He's very squeegee, yeah. Yeah, not too far. Yeah, there we go. And while you're doing that, no, let go. He's in the shape of gel form. So it's very simple. You just pull it out. Now, what do you think that thing on his ear is for? Yeah. So push that thing on the ear. He's back to the old VacMan again. You can start all over again. So this is a very simple toy that was very easily prepared and made that is available in the toy store. Now there are other types of reactions that are not so simple, but they turn out to be. But, this is what I do performance. Now, how simple can you be than adding A plus B plus C? Well, obviously, this is the most elaborate experiment that I'm doing today. It takes the most time to prepare. Because you have to have the right A, the right B, and the right C, and the right concentrations. But it is portable. You can make up the materials on site, and you can carry them to various places. And it will run, depending upon the relative concentrations. As you can see, it will oscillate. This called an oscillating reaction is the original example of oscillating reactions, and it will go on for as long as, I've heard it will go as long as 20 minutes before they eventually do reach equilibrium. All reactions eventually do. It just takes a while. So what you have is a bunch of competing reactions that are proceeding at with different rate constants, and lighter, but also have a and I also have a pair. What I have here is a tube of potassium chlorate. And potassium chlorate is nasty stuff to work with, which is why you're being shielded. I should be shielded, but at least I have goggles on. And one of the fascinating things about it, it has a rather low melting point. So that if you heat it up for a salt, it melts at a fairly low temperature, as you'll see in just a second. It's getting there. The bottom's already started to melt. And this is not enough. There's enough liquid there to probably do the job. And as you see, we don't have to worry about it catching fire, but we do have to worry about putting organic materials in it because it's potassium chlorate, KClO3. So it contains a lot of oxygen. And oxygen does what? Causes things to burn. So it's an extremely strong oxidizing agent. And of course, in our body, the major source of energy in our body is what? Carbohydrates, specifically glucose. And what are gummy bears made of?
Sugar.
Sugars. What kind of gummy bear would you like to sacrifice?
Green one.
Red one.
Green one?
Red one.
Red one?
Red one.
Red, I know I have.
That's the best.
Yeah, red's the best. As you can see, I have all kinds of gummy bears to do all. I've got green too. You want to do a green one? Let's see. Okay. Next time you eat a gummy bear, this is the kind of energy this is how many calories you're putting into your system.
Bring it on.
Yeah,
Don't do a second.
don't do a second.
Don't
Yeah, I guess
see.
the smoke gets a little heavy.
We'll
in
set
here.
off the fire alarm.
Yeah, man, good, well, in fact, I'm right under a fire alarm. I'm right under the fire alarm.
That's what you did last time.
Yeah.
The second one.
I actually did set a fire alarm off at a school that I demonstrated this at one time. Okay, so that's our fifth and the last, oops. We actually have a machine that does that. It doesn't work right now, so I didn't make it this way. Used to make it that way. Oh, let's see. Well, let's see. And this time, watch. I should probably turn off this front projector.
This has been an interesting afternoon.
Is that this one? Watch very carefully. Now watch the tip of the. It's really kind of cool. Watch very carefully. Did you see it? Did you see a blue flame shoot out?
What do you say?
Yeah, this time, there's always one more. This time, watch for the blue flame. That's all, folks. Thank you for your attention. I hope you will try it.